Hello guys, welcome to Hardcoder. Today we are going to see the clean code problem number 12, integer to Roman. Let's dive into the question. So the problem statement is Roman numerals are represented by 7 different symbols. Those are given as follows, and there's given a table which will be mapping the Roman numerals to the corresponding value, and these are given two examples of how Roman representation is used. For first example, 2 is written as 2 i's in Roman numeral, that is what 2 and one two ones added together, and for 12 it is written as xii, which is simply the first x and 2 i's are separated, and number 27 is written as 2x followed by 7 v and 2. So Roman numerals are usually written largest to smallest from left to right. This is an important point to be noted. And however, the numerals for 4 is not 4. Instead, the number 4 is written as IV because it will be taking up a large space. So the Romans during those period have decided to make shortcut for 4. Because the 1 is before 5, we make it subtracting 4. So why they have written as IV? Because I will be representing 1 and V will be representing 5, and 4 will be equal to 5 minus 1. And the same principle applies to number 9, which is written as IX. So the numbers which are contradicting, there is 6 instances where subtraction is used are mentioned in the question, and finally you will be given integer. You need to convert it into a Roman numeral. This is the requirement of the given question. So let's dive into the approach. So firstly we'll copy this. So yes guys. So these are given values, and there is given rule that for contradictory value, that is for 4, 9 and 40, 90 and 400 and 900, there are some other values other than the given symbol values in the given table. So for 4 the Roman numeral is IV, and for 9 the Roman numeral is IX, and for 40 the Roman numeral is XL, and for 90 the Roman numeral is XC, for 400 the Roman numeral is CD, and for 900 the Roman numeral is CM. So how we have formed this? We can able to split up into 3 parts. That is, firstly we are taking the consideration of 10th place digits. Those will be having 4 and 9 as contradictory Roman numerals, which will be using subtraction. So same goes to other groups, in which for 40 we'll be using with 50 and 10, and for 90 we'll be using with 10 and 100. Same goes to 400. So for 400 we'll be using the Roman to represent the number by using 500 and 100, and for 900 100 and 1000 will be taken into considerations. So that's it guys. So how can we approach this problem? So firstly we'll be creating a uh, two array. First array will be storing the instances of symbol of Roman numerals. Let's see 1, 5. So we'll store them in descending order. So it will be M, then followed by CM, which will be represented. So we'll correspondingly add up the uh, values of the symbols. That is, for M it will be 1000, for CM it is 900, for for D it is 500. So for CD the value is 400, For 100, the symbol is C. For 90, the symbol is XC. For 50, the symbol is L. For 40, the symbol is XL. For 10, the symbol is X. Then for 9, the symbol is 1IX. Then for 5, the symbol is V. For 4, the symbol is IV. And finally, symbol I will be having a to represent 1. There are totally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. There are totally 13 entries. You can even use map, but I'm using a array to do the hashing. So let's consider an example of 909. How are we going to approach the solution? So for the given question, I mentioned that Roman numerals are usually written from largest to smallest from left to right. So we'll be taking that case into consideration. So we'll be coming from largest to smallest, that is from M to I. So firstly we'll check if the given number n is greater than or equal to m. No, it is not greater. So we'll go to other next index. So we'll be checking if the given number is greater than or equal to the current value. So it is greater. So firstly we'll be creating a string builder called answer to construct the answer string. So firstly it will be empty, and if we reach a point at which the given number exceeds or is equal to current value, we'll be adding the current Roman numeral representation, and we'll be subtracting the current number from the n. So 900 minus the current value, which is 900, is 9. Then we move on to other cases. So 500 is greater than 9, so we'll move on. So 400 is greater than 9 and 100 is greater than 9, so we'll move on. And 10 will be greater than the given n, and next we'll move to 9. So 9 is equal to 9, that is 9 is equal to n. So we'll append the numeral the Roman symbol, that is ix, and we'll decrement the current value, that is 9, from the given n. And we'll be moving on. 5 is greater than 0, so it will be moving on, and finally we'll reach 1. 1 is greater than 0, so our index will move out of bounds. So finally we have formed the resultant string. So this is it, guys. So let's dive into the coding. So firstly, actually I have already created the two arrays which are required for our problem. And firstly we need to create a string builder with ans, and we'll be creating the object of string builder. Firstly we'll move our index from 0 to start length. So while the given number num is greater than or equal to current index value of nums, we'll add the append the common representation of current number to the answer string builder, and will decrement the value by current value. Finally we'll be returning the answers to string value. So we'll check it up. We'll check with the remaining test cases. It's working fine. We'll submit it up. Yeah, it's accepted. And the time complexity for this approach is of 1. Sorry, it's O of, I'll say, number of digits of num. Why? I'll come to it now. So why I'm saying number of digits, because let's say a greater example in which a string will be exceeding a value. So let's say 888. So for each digit we are going to find the representation. So that's like that. This is all about the given problem. So let's move on to the second approach. This is the first approach. We'll move on to second approach. So let's move on to the second approach. In the second approach, what we're going to do is, if the given number is, let's say 9, 7, 6. So firstly, we'll take up the before going into the approach, we need to basic know the basic concept, like the each digit in our given number is having a specific rank. So 6 will be having a specific rank 1, and 7 will be having 2, 3, then 4. So each rank denotes their superiority. So the digit in the first rank will be called as ones digit, second is tens, hundreds, and thousands. So this is it, and we are going to move based on the ranks. So how can we approach this problem? So firstly, we'll take the first, the largest rank digit, and we'll ignore the other digits. So it will be like, firstly it will be like 9,000. If we firstly ignore the other three bits, other three digits, it will be 9,000, and we'll be finding the representation for 9,000 and appending it to our answer string. So in a given test case, they have mentioned that the given number won't be exceeding and 3999. So we'll try up with the valid test case for our problem. So I'll guess it up. So let's say we have the given number as 876. So firstly, so let's say 3876. So firstly we'll take the higher rank, that is 3. So 3 will be taken and the remaining digits will be ignored. So it will be, after ignoring the remaining digits, it will be 3000. So we'll find the representation for this 3000. How can we find out? We can easily find out by actually we can say the representation for 1000 is m. So till we reach 3000, we'll be adding up the current m. So this is it, and we'll move on to next, the remaining number, the next rank. So the current rank has digit 8, and we'll extract the 8 from the given number, and we'll ignore the other number, that are 7 and 6. So what will be now? So we'll find the corresponding representation of 800 and we'll append it here. So for 800, so for 100 it is L, I guess. Sorry, C. So 100 it is C, and for 500 it is D. So firstly it will be having a D and C, C, C. This is the representation for 800, and now we have moved the rank to 7. So now the extracted digit is 7, and we'll be ignoring the 6. So it will be 70, and the Roman representation of 70 is, firstly for 50 it is L. So L, and the remaining is 20. When we separate 50 from it, remaining is 20. So we'll add 2x to it, and finally we'll move on to the next rank. So next integer is 6 and it is the only digit remaining. So for representation of 6 in Roman, we will firstly add the v, that is 5 and 1. So this is the answer for given problem. So if you have any doubt in this question, it will be cleared in the coding session. But before moving on to the coding session, we'll see how we are extracting each digit every time. That is each position of digit. I mean the number in each rank. How are we extracting number in each rank? So firstly, we need to calculate the total ranks. That is rank count. So for the given problem, it will be 4. And finally, we need to extract the digit from it. So we can do it by let's say digit. We can extract it by using a formula called the given number is nums. So we'll divide the given number by, let's have a helper function mul of 10, which will be multiplying 10 with 1 for n times. So let's pass the n as rank minus 1. So why are we passing it? For currently the rank is 4, so when we subtract 1 from it, it will be 3. So 3 times 10 will be 1000. So finally we'll get digit. It will be let's say it's an integer digit as 38. Actually sorry, it will get 3 in the digit. So once again we'll do a modulo operator with modulo operation with 10. So finally we get answer 3. So here it is it may seem unnecessary to have a mod 10, but it will be helping you in next cases. So I'll discuss those soon. So we'll firstly have extracted digit 3 of the current rank successfully. So after finding the after extracting the current digit, and we will firstly have a string representing the first position of the current rank. So our current rank is 1000. So 1000's current rank, the first position of current rank is 1000. So for 1000, let's say first. So we can use a map and get the value of 1000. That is how 1000's value will be m. And we need to find the fifth position. So it will be 5 and next ranks first position. Next first. Let's say next first. So in this case, we don't need to go on to other steps, because the given problem will be having only two number can range only up to 3910. So let's consider 5 as question mark and next first as question mark. So we have constructed this, and we are just going to make changes based on the given digit. So if digit is 9, we'll append the first followed by next first. If digit is for 4, we have another condition, and if the given digit is greater than or equal to 5, we have another condition, that is append only 5. For 4, we will append first and 5. So for 1, so till the current digit is not made to 0, greater than or equal to 0, will append, that is first, and finally we'll decrement the rank to 1. We'll decrement the rank by 1. So this is the approach we are going to use here, and if you are not clear here about the approach, you can, I'm sure that you will be able to understand the approach in the coding section. So guys, firstly we can create a map which will be showing the integer as a key and followed by string as value. So we'll call it as Romans, and we'll add up the Roman entries. So we'll pass the Romans into a helper function, and finally we can have a string builder. And so firstly we need to find the rank of the given, the maximum rank of the current number. So we can have a helper function to find out the rank. So in rank count helper function, find the total number of digit. The total number of digit will be the maximum rank of the given number. So let's say count, and while number is greater than 0, we'll increment the count, and we'll divide the we'll remove the digit a digit from the number, and finally we'll return the count. So this is what we have done, and while ranked number is greater than 0, we're going to get into the loop, and firstly, as I have mentioned, we'll find the first position. Firstly, we'll find the first position of the current rank. First position, it will be Romans dot get uh, mul 10 of rank now minus 1. So what have, so I have a helper function mul 10. Wait a second. It will be multiplying the number, so let's say val, multiplying the 1 into n times, while n is greater than 0 and we are decrementing it for each operation. We'll multiply the val into 10, and finally we'll return the val. So the map helper function will be having a count n as an argument, and it will multiply n times with 10 with 1. So firstly we'll need to find the first position of the Roman numeral of the current rank. We have found out it, and next we'll find the fifth position. It will be 5 into mul 10 into rank now minus 1, and the first position of the next rank. Next, first Romans dot get next rank will be, we don't need to subtract anything, so giving the rank number will be helping us to get the move to the next rank. So it's done, and finally we need to extract the digit in the current rank. So digit will be current number by mul 10 of rank number minus 1. This is the case. So finally we'll mod it by 10. So in some cases we'll be getting a wrong value. In case of 20, when we go to 0, the mul rank will be returning 1. So in that case we need to have 0. So in order to do that, if rank number is greater than 0, we'll move on to this approach. We move on to this, or else we'll simply use digit as the current digit. That is, in case of one digit number, so we need only one digit. We don't need to check for any other conditions. That's it. So if we are going to change, append the Roman numeral based on the given data digit. So if digit is 9, we'll append the first question followed by next first question, and digit is reduced by 9. Else if digit is 4, we'll be appending first question of current rank and fifth question of current rank, and digit will be made separated by 5. And else if digit is greater than or equal to 5, we'll append fifth question, it's -4, so we'll subtract by the given digit by 5. And finally, while digit is greater than 0, we'll append first question and we'll decrement the digit by 1. And finally, after these statements will be able to find the representation of Roman representation of given rank. After finding the Roman representation of the given rank, we move down to the next rank, that is rank number minus S. So this is it, guys. So firstly, we'll check it out. So num mod. So it's working for sample decrease. So what I have done here is consider a number like uh, 444. So I'll type it here, 444. When the rank of the given number is as follows: the first four, so let's say 4, 8, 9. Rank of 4 is 3, rank of 8 is 2, and rank of 9 is 1. So when we reach the condition that rank is greater than 0, so rank is greater than 1. So if the rank is not in the current, last rank, we can divide it by given multiplied rank number, or else we'll mod it by 10. So let's try it. So let's also consider this case 20. So working fine. Let's submit it up. Yeah, it's working fine.